Here we're looking at question 4, part B. This one, it gives us a volume and moles of some different components. So the first thing, as always, we will write our K expression. Since it's given in moles and liters, we can know that the values are going to be in molarities, which is why I have the square bracket and why it's labeled as Kc. Then it's important to think about the amounts that they're giving us. Are those starting amounts or final amounts? Are those initial or equilibrium? So it says initial here. So I divided those moles by the 1 liter to put those as molarities, but it didn't tell us anything about chlorine. We assume that to be 0. Then it tells us an amount for chlorine, but it says that's at equilibrium. So that goes down here in the E or equilibrium box for that chemical. Now we need to calculate K and all of our equilibrium concentrations. So what's really important here is focusing on the C row. The C row is change. Which thing is decreasing and which is increasing? And by how much are they increasing and decreasing? So the values, whether it's a 1, 2, 3, 4, or 5, is based upon the coefficients, all of which are 1 on this problem. The sign, whether we are adding or removing it, is based upon which way the reaction needs to shift based upon the chemicals that we have. So we have some of this, but no chlorine. So we definitely, during this reaction, will be making chlorine whenever one of your chemicals, whether it's a product or a reactant, is 0. That is the side of the reaction that would be either plus X or plus 2X or plus 3X. So since we're making chlorine, when doing that, we would also be making the phosphorus trichloride. In order to make those, we need to consume the phosphorus pentachloride. So then we combine those things. The amount minus X is how much we have in equilibrium. The amount plus X is how much we have at equilibrium. 0 plus X is how much we have at equilibrium. And because it tells us the amount of chlorine, we can figure out that if I had 0 plus X and that's how much I have, then X has to be equal to 0.002 moles per liter. So then we plug that in for the X. We do 0.0087 minus the 2 to the negative third, the 0.298 plus 2 to the negative third. And then after we've done that, we have our final equilibrium values. When we plug those in, down here, sorry about that, we are able to get our K value, and then we can answer whatever other questions would follow this in an AP problem about which side is favored and making any connections to changes in conditions. What's really important, whether it's multiple choice or free response, is setting up the rice table such that you know, are the values given in the problem my starting or my ending values? As you get more familiar with this, it'll become easier and easier, but it also becomes tempting to kind of skip that step and try to just plug a whole bunch of numbers in, especially on a multiple choice. So take that little bit of time and carefully read and put them into a rice table.